In this video, we will find the equation for a line which is the intersection of two planes. So first thing, maybe let's look at this first equation for a plane and simplify it a little bit. If you notice, all the coefficients are divisible by 5, so we can write that same equation as y plus z equals negative 4, just by dividing everything through by negative 5, by 5. Okay, now the idea here is both equations have z in them, so we're going to solve both equations for z and set them equal to each other and see what we get. So in the first equation, it's pretty easy, just move the y over. We get that z is negative y plus 4. Both terms will have a negative sign on the other side, so we factor it out. Now do the same thing with the other equation. So the other equation, we start with x plus 4y plus 3z equals negative 19. And again, do the same thing. Just solve for z, so move the x and y terms to the other side and divide by 3. So we'll get that z is negative 1/3 times x plus 4y plus 19. Okay, so now we have two equations, and they're both solved for z. So z equals both negative y plus 4, and it equals negative 1/3 times x plus 4y plus 19. So since both things are equal to z, they are equal to each other. So now we set the right-hand sides equal to each other, and this tells us that y plus 4 is equal to 1/3 x plus 4y plus 19. So here I've canceled the minus signs in the first step. Now maybe let's multiply both sides by 3 to cancel that 1/3. So we have 3y plus 12 now on the left, and on the right we just get rid of the 1/3. Okay, now just move stuff around. So let's maybe put all the x's and y's on the right hand side. So just move the 3y over. So subtract 3y. So that brings this down to just 1y. And move the 19 over, and we get negative 7. So here what we found out is that where these two planes intersect, the x and y coordinates along the intersection satisfy this equation right here, that the sum of the x and y coordinates is negative 7. So from this we can write a vector equation for this line. So the idea is to do this. Let's just pick one of the variables, either x or y. I'm going to pick x, and have that be your parameter t. Then everything else is determined now, because now we know what y is in terms of x by this equation circled in blue that we just found out. Right, so if we just solve for y, we know that y is negative x plus 7. But we chose x to be t, so this is the same as negative t plus 7. And then similarly for z, use either of the two equations that we started with. Maybe let's use this one, since it's simpler looking. So z is negative y plus 4. And we have y right here, so it's this whole thing plus 4, and then the negative of that. So negative, and then substitute this expression in for y, plus 4. And if you sort of cancel the minus signs and get rid of the parentheses and simplify this, this just comes out to t plus 3. So to summarize, just found out, the line of intersection of these two planes, let's call it L of t, or vector function, is, so let's just use these things that we got. So the x component is just t, the y component is negative t plus 7, and the z component is t plus 30. And that's it. This is the line of intersection of the two planes that we started with.